So when we're thinking about doing statistical analysis, it's really important as a foundational, like very first step to understand your data and some of the limitations and quirks of it. And this is something that I don't think necessarily it's communicated well enough when we teach statistics as a statistics course. And so I think it's as a research methods course, this is a good place to introduce it. So just as a foundational piece, when you get a data set, you should always begin not by crunching the numbers, but by scrutinizing the data to figure out what it is you're working with. Right. And so even if it's your own data set and you created it, it's useful to always start up by looking back and see, did you remember to label things? Did you label things correctly? Oftentimes when we're building data sets, we are kind of in the moment and we don't always keep notes or keep track of exactly what we did or build code books that go along with that. And so it's always useful while your memory is still fresh to figure out what things are. And if it's not clearly labeled, to maybe dig in and investigate so that you can provide those labels. It's also useful to figure out if you made typos or other data entry mistakes. And so when you run a frequency table, or I use pivot tables when I'm using Excel, to kind of get a sense of what are the values in that data set that can help pick out if you maybe keyed something in incorrectly and have sort of an odd case, that can be really helpful. If somebody else created the data set, right, it's really important to go back through their code book, assuming they have one, and figure out what the heck the variables mean, because there are all sorts of transformations you can do in data with variables or changing the scales. One common thing that I come across is I'll be working with GDP numbers, and I never really have a sense of whether it's in thousands or in millions, because the numbers are kind of big and they all kind of blur together. I don't really have a detailed sense of what Senegal's GDP in 1965 really would have been. And so it's useful to kind of dig in and investigate so you know exactly what you're looking at with that data. It's also really important to know how missing values were handled. We're going to spend a lot of time talking about missing values, because if you get this wrong, it can really mess up your data and do some awful things. Some data sets will include, or will just leave things blank for missing values. In some data sets, they'll use something like NA, which like not available, which will clearly not show up when you run a statistical analysis, but might sort of weirdly turn your column into a string rather than numbers, which make it trickier to analyze depending on your statistical package. And some data sets will use a numeric code to indicate that something is missing data. So it might be, -9 or -99 or -999. And if those values are in your data set as missing values and you run your averages on that data, your average values are going to end up being a lot lower than they should be, because it's going to treat those missing values as numbers rather than as indicators that there's nothing here. And so knowing that and then adjusting for that, getting rid of those missing value codes if you're going to run your statistical analysis, or at least declaring them depending on what statistical package you're using, is going to be essential. Second piece, once you've sort of got your data in place, I would encourage you to not use statistics to lie. Statistics provide summaries of many cases. And by definition, statistics leave out information, and that can be useful, right? As we're trying to communicate what's happening in data, we're trying to communicate things that are useful to people who can't sort of scrutinize the whole thing. And so we provide stories about central tendency as a way of getting a sense of what's normal. But central tendency doesn't tell us about how spread out our data is. So maybe we have to communicate also how spread out things are, but that doesn't communicate skew. And so I would maybe say that the way to approach this isn't by trying to report as much information as possible. It's to think about the following, I guess, joke, story, anecdote, made up thing. It's the statistics joke about, did you hear about the person who drowned crossing a stream that was only 6 inches deep on average? If you know anything about averages, you know that an average doesn't tell you about sort of everything in the data. That stream could have been 2 inches deep for most of it, but there was a great big hole in the center, and that's where you fall in. That's the way to think about reporting information with statistics, that your job is to communicate the important piece of information, which is the stream is pretty shallow, but there's this great big hole in the center there. That's an important piece of pairing of information, whereas the overall average or even the standard deviation isn't particularly useful when what you were really interested in is there's the hole, don't step there. It's also possible to cherry pick your statistics in a way that emphasizes certain patterns or de-emphasizes others. Doing statistical analysis with subsets of data or restricting your data in some way can create impressions that things are going on that don't hold up in the whole. And so again, I would maybe circle back to, are you doing that because you really want to find a pattern or you really want to hide a pattern? Or are you doing that because you're trying to illuminate something that is important for people to know? And I think there are a lot of decisions that would be sketchy if your motivations were, I'm trying to hide something or I'm trying to tell a lie. That make a lot of sense if we're trying instead to say, this is something you really need to understand. And so I guess the underlying thing is that there's not necessarily good statistical practice and bad statistical practice. There's ethical statistical practice and unethical statistical practice, because things that might be sketchy in one situation might make a lot of sense to communicate in another situation. And our instincts as researchers and as communicators of data to provide the important story is really the difference between those two scenarios. Okay, let's talk a little bit about missing data, because this ends up being potentially a huge mess in statistical analysis, and I think it's worth spending some time thinking about what it can do. Oftentimes when we collect data, we don't have values for every single variable, right? So sometimes people, when they're taking telephone surveys, they hang up the phone or they decline to answer a particular question. Sometimes if we're collecting data on countries, there's just no data for Senegal's GDP 1965. It just doesn't exist. It was never collected and you can't get it. And so when you have this missing data, the question to ask is sort of, is this going to be a problem for me? And it depends. It depends on the kind of statistics that we're doing and the size of our sample, right? So if you have a very small sample and, you know, a third of your cases are missing, you're going to find yourself in a situation where you might not have enough cases to really do any sort of statistical analysis. This problem gets worse when you start doing bivariate or multivariate statistics. If you're just calculating an average, which is sometimes called a univariate statistic, where you're working with just one variable, you just ignore the missing stuff and you calculate your average. But if you're running a correlation, correlation looks at pairs of cases or pairs of values in a single case. And if one of those values for that case is missing, you can't use that case in running your correlation. And so if you have missing values, but they're always in the same case, you've reduced your overall sample size. But if you have missing values and they're in different cases on different variables, every single time you encounter a missing case, it kicks that out of your analysis. It can't run it. And as a result, you could end up with very few cases in your analysis, or potentially creating a biased sample because of the way that the missing cases play out. And that really leads us in this question of, why is that data missing? Like, what's the process behind that? And ideally, the reason data is missing is, or could be described as MCAR, missing completely at random. That there is no rhyme or reason to why this case is missing a response on that variable versus that case. And when that happens, we can almost treat missing data as like a secondary sampling process, where I take a random sample, I get 1,000 cases, and then I take a random sample of maybe 100 cases from that I'm just going to delete. And so it ends up being as if I had a random sample of 900 cases, because 100 of my cases randomly were excluded because of missing data, right? That's fine. My sample size got smaller, but my results are still a random process, and it shouldn't be biased. It should still behave the way random samples do. However, that's often not the reason for data to be missing. Oftentimes there is an underlying story behind why that data is missing, and we can't assume that it's missing completely at random. So why might it be missing? Well, it might be that something about that question caused people to say, or caused a particular subset of people to say, yeah, I'm not answering that. Right? And again, I've used the example in the past of things being correlated with public trust, that people who are more public, have greater levels of public trust are going to be more likely to answer survey questions when random strangers call them up, but also are going to have different responses to lots of social science questions than people with low public trust. And so it's actually not random who answers that question. It's linked to something else that's really important to understand. Another place where we've seen this is in development economics, where for decades, development economists ran their analysis on data from countries that had collected data. And they developed models about what helped with economic development in countries that had been collecting data that could help them to study economic development, not thinking about all the countries that had failed to collect data and the reasons behind why they had failed to collect data, and how countries that were collecting data in the 1950s and 60s might be different than countries that hadn't developed the statistical capacity in terms of government functioning and government research institutes to be able to collect that kind of data in the 50s and 60s. And maybe that was a proxy for lots of other things that were either going right in a country or wrong in a country that they weren't able to pick up on and measure. And so as a result, a lot of their analysis ended up being flawed because it was assuming that the patterns you found looking at countries where there was data in existence could be applied to countries where there wasn't. And that just wasn't the case because there was a underlying process causing that missing data. So I think it's very important to think about the process that might produce that missing data and to communicate potentially the limitations around that. So that's sort of the big picture, sort of philosophical level about what do we do about missing data. At a practical level, if you have a lot of cases that are missing, that's going to create some sort of weird mathematical things that I think are worth knowing. And so one of the ways that we differentiate this is actual percentages versus valid percentages. An actual percentage is looking at the number of cases that have a particular value. So let's say I'm interested in people who report unemployment. And so I tally up the number of people who report that they're unemployed, and I divide that by the total number of cases in my data set. Right? That would be the actual percentage of the people in my data set. This is what percentage are claiming unemployment. But if a large number of people decline to answer that question, that might be a smaller percentage than if I said, well, I had 1,000 people in my data set, 200 declined to answer. So instead of dividing the number of people who did answer and say, yes, unemployed, by 1,000, I'm going to divide that by 800 because I have 800 valid responses. Those valid percentages are going to be a much larger value. And the gap between actual and valid percentages is going to change and get larger as we get more and more missing cases. So again, I think it's worth thinking about how we calculate basic statistics when we have large amounts of missing data and what story that's communicating or not communicating. And then finally, circling back to this idea of missing data at random, it's worth flagging sort of the survivorship problem. And this is sort of a famous anecdote in statistics, where initially statisticians working for, I guess it would be the War Department, now the Department of Defense during World War II, were trying to figure out how to make bombers more resistant to enemy fire. And so they analyzed where the planes were being hit. And they were going to put extra metal and extra shielding and extra armor on those spots where there were lots of bullets hitting the planes. And it wasn't until it was pointed out that you really shouldn't look at planes that survived enemy fire. You should look at the planes that were shot down. That's where you need to provide the shielding. But since you don't have those planes available, maybe you should look at the places where the bullet holes aren't, because those are the places where a plane was able to avoid getting shot and make it back. And so this problem shows up all over the place in the social sciences, where we find ourselves looking at cases that are available to us, and we don't necessarily consider why are those cases available to us? Why are other cases not available to us? And maybe there's something different and important about the cases that are available to us versus the ones that aren't, that is going to lead us to drawing false conclusions based on the ones that we have. And one place where or another way that this is often talked about is selecting on the dependent variable. This problem shows up all over the place. My favorite example comes from a book written by Napoleon Hill about sort of the secrets of gaining wealth. And Napoleon Hill was commissioned by Andrew Carnegie in, I don't know, the 1900s, 1890s, to go and talk to all of Andrew Carnegie's wealthy friends and figure out what are the secrets that make people wealthy. And Napoleon Hill came back with lots of interesting anecdotes, like take afternoon naps. As things that will help you be successful, but he was only talking to sort of fabulously wealthy people who had made it through, when he should have been talking to folks along the way who didn't sort of make it to the status of the ultra wealthy, who maybe were doing similar things, or who maybe had a different path for reasons that you're not going to be able to see when you just look at the successful cases. So again, when we're thinking about data, it's really important to think about that data generation process so that we know what the heck it is we should actually be looking for, communicating, and the caveats around that data that we need to provide so that we're not misleading people with that data.